Yeah, I think you can see my screen now. So yeah, hello everyone. I am Shriram. I'm currently a PhD student. I'm from originally from South India, from Tamil Nadu. Just an overview of the session. I'm just going to give like a brief introduction about myself and then just chronologically go through my journey, kind of from schooling to where I am now, just to show how I ended up where I ended up. And along the way, like I'll be giving like brief, like technical overviews wherever it's appropriate, right? Um, I finished my high school at Bharati Vidya Bhavan. It's kind of I guess all over India. So like you may have heard of it, but like I've completed it in Coimbatore in Tamil Nadu. And then I finished my bachelor's in electrical engineering. And then I did a market research internship at McKinsey, which is a bit of a left turn. It's not necessarily related to engineering, but yeah, I just did it between the gap of like joining my master's and like finishing my undergrad. So and then I did my master's in computer engineering from Virginia Tech in the US. And then during my master's in the summer of 2022, I did a firmware internship, which is somewhat related to the previous session that we've had, the embedded system session, which is somewhat related to embedded systems firmware. So I did it in a semiconductor company called Marvell. And now, last year, August, I joined my PhD program in computer science at Boston University. So just to like start from the beginning, my interest in computer science, I guess, began right from my school, where I developed an interest in general for teaching and an admiration for teachers, which is eventually what led me to pursue a PhD in the first place. But more importantly, I would say I also developed an interest for computer science because I was lucky enough that our school actually taught programming right from like sixth standard, which might be common nowadays, like at least teaching programming. But I'd like to go on a brief tangent about why C programming is like a really appropriate language, maybe a appropriate first language to learn. So those of you who are, I guess, more familiar with computer science, I understand there may be undergrads who are watching this, or even high school students. So like people who are familiar with something about computer science, like areas like software development and machine learning are usually the most popular ones. Like everybody is aware of, even like non-technical people who are not working in computer science. So if you were to compare like the languages that you need for different areas, systems is basically my area, like operating systems. In general, it's just called computer systems. If you were to compare both of them, some of the languages that you might generally be expected to know if you go into software development or machine learning are Python, Java. There is R, which is used for data processing for like statistics and stuff. And if you want to create like beautiful websites which are responsive to the user, you need JavaScript and also HTML. But on the other hand, for systems research, anywhere from like very basics to all the way to like my PhD right now, for operating systems, basically the only language that I use is C, maybe C++. I mean, you also need to take what I say with a grain of salt because like I'm obviously biased towards systems because that is my area, my area of interest and expertise. But I also do believe like it is important to learn a more fundamental language. So like if you are, and from what I hear, it's like nowadays, like the first programming language that every engineering department is taught is also Python, which is like in general good for a software development job. But like as a fundamental basics for computer science itself, I would say learning a more basic language like C is more helpful because like at the end of the day, if you ask any software developer, like like with Python or like with any language, actually, programming is a lot of just Googling for stuff that you need. But with C, there is actually, you can actually get an understanding of what is actually happening in the computer, how what you are writing might get executed in the computer. Whereas for a more complex language like Python or Java, like there are more steps in the translation from what you write to what is actually done inside the computer. So like there is less awareness of what is happening in the system. So yeah, that's my tangent about like languages. Um, Coming back to my undergrad, that is where I was introduced to operating systems and specifically real-time systems, which is my specific area of research, real-time operating systems. But also, like, it would be amiss if I did not mention, like, I guess my failures or something that I thought would have been better for me, but I did not get. As I mentioned, like I had chosen electrical and electronics engineering. But the reason I chose that was kind of funny. Like I did not even consider computer science and engineering because it was my score wasn't good enough for that. That is like one big difference between, I would say, like the Indian system and generally the US system. Like there is a single number, there is a single cutoff mark, like your 12th standard or your IIT JEE score or whatever it is, and like that just decides your next 4 or 5 years, or maybe the rest of your life, right? But that's not really the case in the US. I'll elaborate more on that later. But that's the reason I did not choose computer science and engineering. But the reason I chose electrical engineering also, and like I'll be talking more about this, but like I'm like generating a story where I can draw like a straight line from my high school to my PhD, but it wasn't really that deliberate, that planned. I really chose electrical engineering because that was the one area of engineering that neither my father nor my mother suggested I study. So I just wanted to like be a contrarian, like do something that they did not want me to do. It turned out well for me, but like yeah. And of course, like I like several other engineering aspirants, I wrote several competitive exams, among them to BITS Pilani. I did not write IIT JEE. I was not that confident of myself. But like I did not get into BITS Pilani either. Like I just got into PhD College of Technology, which is a pretty good college, which is in Tamil Nadu. But there are some upsides. There are some of you who might be wondering about like transitioning to computer science to any area, not just systems. Where I think like areas like electrical engineering or even electronics engineering related fields can be actually really helpful. Like a background in that field can actually be really helpful. So so if you see, this is like a view of like a computing stack, like what are the different things that exist in a computer, like anything from your mobile phone to your personal computer, like a desktop computer. At the base level, you have like your hardware devices. The actual chip is made up of several transistors, like your Intel, whatever chip that you use, or like a Snapdragon in your mobile phone. At the end of the day, it is just several transistors. Those are the devices. Several of the transistors are brought together to form digital circuits, and like several circuits connected to form units that perform certain tasks. So you have your arithmetic unit that performs arithmetic operations, addition, subtraction, and so on. And then they come together to form your microarchitecture, like your chips. And then on top of that, as you can see, we are moving away from hardware to software. So you have your scheduler, compiler, which is again a part of the operating system. And then at the higher level, you have algorithms that run within your operating system and like applications that run. What I have found with electrical and electronics engineering and related fields is like you get a lot of insight about this portion, like the hardware part of your computing stack, which is not really focused on in general computer science education, even in computer science and engineering in India to that level of depth. And it does help. As I mentioned, it is helpful to know from bottom up what is happening inside your system, especially for research into operating systems, because that is the study of like how you manage your entire computer. So that is what I'll be going over next. Um, so this is like an image from a very popular operating systems book by Silberschatz and other authors. So if you consider, it's like a brief overview over operating systems. If you're not familiar, you have in your computer, the user can view applications such as like Chrome or MS Word or Google Drive or whatever apps you have in your phone. Those are also essentially application programs. And at the base, as we have discussed, we have hardware, which is either Intel processors or Snapdragon processors or whatever chip is in your device. But in the middle, basically something that manages the communication or the allocation between or the interaction between the application layer and the underlying hardware is your operating system. And of course, examples of operating systems are the most popular one for desktop systems, Windows, Android in mobile phones, iOS in Apple phones are general examples of operating systems. Um, so it essentially manages the entire computer. That is what an operating system does at the end of the day. But one important point about operating systems, like Windows and Linux or other operating systems, is that they are usually designed to be real fast. That is, they are designed to finish as many things as possible in as little time as possible. That is what they're optimized for. They are not really suitable for certain critical applications, which I'll be discussing now. Um, so autonomous vehicles, these are like a latest trend. A lot of countries are enforcing or planning to enforce environmental pollution restrictions on companies. And of course, cars form a big portion of air pollution and other forms of pollution. So there are like restrictions on the industry to move towards electric vehicles. And when you move towards electric vehicles, there is also, with the development of AI, there is a need for there is an opportunity to develop driverless vehicles, right? Instead of having a driver there, say you don't know how to drive a car, or you can't drive a car, like say your leg is broken that for a month, so but you still need to get to work. You can have a driverless car. Say a bus is not available there. India has very good public transit. The US does not. So you need to travel in cars everywhere. So in those situations, of course, an autonomous vehicle, basically something that can drive without supervision, is very helpful. Without any driver, basically, is very helpful. So that is an active area of research, as well as a lot of money is being spent in the industry trying to develop technologies for it. But with autonomous vehicles, there is also a need for communication between different autonomous vehicles. So right now, like as drivers, like you are aware of other drivers around you, like you can communicate with them. Like for instance, a very common thing in India is like bike riders, at least who are coming opposite to you, will actually let you know if there is like a policeman in front checking for helmets, stuff like that. Like, for instance, you need communication between drivers, basically. So there is also a need for communication between vehicles. If there is no driver, the vehicles need to communicate with one another. So there is a need to move towards connected autonomous vehicles. So you need a network of vehicles. So this adds a lot of complexity, as you can see in this AI generated image, actually. There are a lot of sensors. There's a lot of technology that goes into a connected autonomous vehicle. So to manage all this, you actually need an operating system. So there is a move towards basically making your car like a computer on wheels. There is already a computer in your car, probably for like the music system, but and there are several other computers as well. But like there is a push towards a single computer controlling everything in the car. So in that case, you also need an operating system, because you need an operating system whenever you have a computer. But if you had an operating system like Windows or any other desktop operating system, say the car detects that it is going to hit a tree or a pedestrian, but we'll take a tree as an example. your general operating system, like your desktop operating system, would probably, if it encounters such a huge fault, it would just like stop, yeah, throw you like a blue screen, like throw some error, just turn off or something like that. That is, of course, not acceptable when there are lives at stake, when there are human beings sitting inside the car who need to be protected from whatever is the obstacle that's potentially when a car is potentially heading for a collision. So in those cases, you need like an awareness of time, like you need to respond quickly before you can hit. Like for instance, if you in cars right now, before you collide, like I mean, when an impact is detected, you need to inflate the airbags. So that is of course a need where that is of course a situation where you need to react very quickly. So in those cases, you do not care about speed necessarily, but it is about like predictability. Can we say with 100% guarantee that the people inside the car will be safe? Like, will the airbags deploy at the right time? That is where you have the need for a real-time operating system, where basically in your general operating system, you just have like several tasks. You have a browser open, you have a word processor, you have MS Word, you have a Paint or whatever open. You just need speed there. You just need them to work reasonably quickly, or you have Zoom open, or you have YouTube open. You just need them to work quick enough for you. But there is not really a sense of urgency. But in critical applications like this, there is a need for timing predictability, where tasks actually have deadlines. That is where a real-time operating system comes in. That's the general difference between a general purpose operating system like Windows or Linux and a real-time operating system. So I was lucky enough to be introduced to this area and to general operating systems during my undergrad. So that led me to, and my general interest in teaching led me to pursue a master's. And of course, there are several reasons to do the master's in the US. So one thing is, again, as I mentioned, like the Indian system is much more rigid. Like if I joined the EEE department, the electrical and electronics engineering department, but if I wanted to switch to another department, say I wasn't happy there, I studied for a semester. I realized I did not like it. The only option I had would be to drop out. At least in my college, the only option was to drop out and like attend counseling again, which I understand is the case in a lot of colleges, a lot of universities till now. There are certain options in IITs, but still it's not that common in India. Whereas in the US, like changing majors or changing your program is much more doable, relatively speaking. It's much easier compared to India. That you can see by me moving from electrical to computer engineering itself. So, and also on average, this is like a very broad statement, but like on average, things are better in the US. It's not like I don't want to paint like a rosy picture saying like everything is better here, but on average, things are generally better than in India. So during my master's is when I first learned Linux kernel programming. So if any of you have like work experience or like if you are even familiar with like using Linux, you know more than I do, more than I did when I started my master's. So I knew nothing about Linux. I did not even start using Linux before I started my master's, which was just 3 years back, like 2.5 years back now. So I won't say it's not hard, but you can pick it up. It's not impossible. And something else that I also want to delve a bit into is the specific part of real-time operating systems that I did research in during my master's, which is scheduling. But of course, like there are downsides, right? Like things are better in the US, but of course, one big downside is the isolation. Like I had friends who came with me to the US, but it is still not ideal to like I spent most of my life in the city where I was born. And like I know the language everybody is speaking in. Oh, by the way, apologies for that. I'm not it might be better if I speak in Hindi, but like I'm not very good at Hindi. But like that I think you can relate to that probably. Like moving away from home is like hard enough within India, but like when you are like a 20-hour flight away from home, and the flight is also like probably lakhs of rupees, so like you can't just go whenever you want. That is a bit isolating. Like in the last 2.5 years, I've been to India like once. But there are of course upsides to it, as I mentioned. But you just have to manage your expectations accordingly. That is my idea on about mentioning this. It's not supposed to be discouraging or painting too much of an optimistic picture. Um, so there are, of course, a lot of questions and nuances when it comes to applying to the US. I'll be giving like a general overview. If you have any more specific questions, of course, like you can if you are watching live, you can put it in the comments, or like you can reach out to me by email. That's the best way to reach me. Like a one common exam that you might need to take if you are applying to the US for any graduate study, actually, not just masters, even for a PhD, you usually need a GRE. Some universities say we don't need it, but like you can check the university's admissions page for more information on that. But in general, it is good to take the GRE, and it is basically just English and ninth standard maths that you can just do without a calculator. And it's also not complicated like calculus and stuff. So it is simpler math. Indians usually, from what I've seen and from what I went through, usually have more trouble with the English part of it. The math part of it is fine. And there's also, along with GRE, usually there is at least one English proficiency test, either TOEFL or IELTS. Both are also like they have several components like reading, speaking, listening, writing. Mostly for these three, I would say any two of these three that you decide to take if you are planning to come to the US. Most important thing would be practicing vocabulary. There are several free apps for that on the Play Store that you can download and use, like just like a quiz type thing or like a fill in the blanks type. Because like learning more complicated words is usually the biggest barrier, I think, for specifically for Indians, because we are not native English speakers, even though we are generally good in English. But there are also, of course, other factors, like you need a statement of purpose, basically explaining your purpose, like why you are coming to the US, why you are pursuing this master's, why you are pursuing a PhD, how this will help you in your career, stuff like that. Of course, one big reason for people applying for masters in the US is the US salary is better. $1 is, I think, equal to now 80, 84, 85 rupees. But you can't be that honest in your statement of purpose. But also you should talk more about why you like your area, because hopefully you like your area of interest, right? Like if I applied for like computer engineering, like I should explain why I like computer engineering, why I'm studying computer engineering. So that is what is needed there. And letters of recommendation was something that you would get from your professors, undergraduate or master's professors. And you can also get it from, if you have work experience, you can get it from your senior colleagues or from managers. But one thing you should note is universities in the US give more importance to letters from professors than to the industry letters. If they ask for three letters, they actually specify that two of them should definitely be from professors. So if you are planning on graduating soon, if you're applying for if you're thinking of applying for masters a few years later, but you're graduating soon, maybe try to keep in touch with some of your professors, the professors that you like the most, so that you can ask them for a letter of recommendation later. And of course, like your CGPA of your college is a factor. But like one thing that you need to understand is kind of a good thing about the US is like it is not everything is not reduced to one number. It can be a good thing and a bad thing. The good thing, of course, is like if you do not have like such a great CGPA, but like you can compensate it with a good statement of purpose, say a good GRE score, those factors can still boost your application. It's not just one number and like that just decides whether you get in or not. It's not a clear cut cutoff. But of course, the downside is for Indians who are used to that simple, no complication system, this can be more complicated because like there are so many factors that you need to consider when you are applying for a university. In India, you can just look at the cutoff and decide the ranking of the university, or look at the ranking and you'll know the cutoff range, basically. It's not so in the US. Like you don't have a clear cutoff for any program. Those are the additional complexities. And of course, the big factor is money. You need a lot of money just to apply to the US. GRE is around 200, maybe more dollars. I don't remember the exact price now. TOEFL is also $200, which again multiply by 80. So it's like close to 20,000. And like each application can range to like $100. So there are a lot of things. And of course, when you come here for the tuition expenses and living expenses, you need to take the money. So like a lot of people do work for a few years and then apply for a master's when they have like a good amount of savings saved up. And also that experience does help your application a bit. It's not necessary, but like it definitely helps. So this all leads to like a very important decision, like which university should you apply for? Which is again like a very complicated question. It depends on what you are looking for, what your goals are, what your factors are, what are these, where do you stand with your GRE, TOEFL, like your CGPA, how much money are you willing to spend? So for instance, with me, a lot of the universities in the US do have scholarships, and there are Indian scholarships that are available, which you can apply for higher studies abroad. I haven't explored them too much because like the university that I applied to for my master's actually has a lot of quite a few teaching assistantships where basically you help teachers with their course. Like say you are a master's student, so you help undergrads with their help the teachers, professors teach the undergrads. Say you grade their papers, you clarify their doubts. It's called office hours. If you're not familiar, I wasn't familiar with that concept in India. For those things, depending on your university, you might get a complete tuition fee waiver. You might get a stipend on top of it, like every month. You'd actually get enough money to cover your living expenses. But apart from that, for generally living expenses, Indian students, international students in the US usually work part-time, either in the dining center or as a grader for courses. So there are other financial things that you also need to decide. The best thing I would say is like contact current students. Like if you have a list of universities that you might that you're thinking of applying to, look up the current students on LinkedIn. Usually people who come to the US generally update their LinkedIn because like that is usually important for applying for jobs. So just find like a list of people who are in the program that you're interested in the university that you're interested in, and just message them. If they don't respond, message them again after a few weeks. Like people are not after a few days, people are not really that responsive on LinkedIn, but like that's another thing that you need to learn when you come to the US. It's okay to be shameless. It's okay to spam people until you get what you want, basically. I would say within limits, of course. This doesn't really hurt that much. So this is like a general overview, like a very high level view of like applying to the US. So a little bit more about scheduling research. So say you have like three tasks in the system. There are like different ways in which you can arrange them, right? Like, and scheduling is just the English meaning. Like you have several things that you need to do. How do you schedule them? And like one thing that I like to think about myself is like I'm very bad at time management myself. So that is why I like to manage the time of decide how the computer manages its time. So that is the part of operating systems. Scheduling research is a part of operating systems that deals with scheduling the different things that happen in your computer. So there are different, what order should these tasks be scheduled? Like, should it be 1, 2, 3 or like 2, 1, 3? Because like 2 looks like the shortest one. So should we have the shortest job first, or should we have the longest job first? Here it looks like task 1 has been split into 2. So maybe we should have both of them together, like finish the longest job first and like have the shortest, maybe easier job for later. We might have different ideas like in practical life based on different things, but like a very straightforward way is based on which task is the most important. And in real-time systems, as I mentioned, you have deadlines, right? So like a very simple way is assign priorities to tasks. And the priorities basically is like importance, right? Which task is most important. So you have a homework deadline for tomorrow, and like you need to make a like make a birthday card for your friend or something for next week. Like this task is currently most important, that tomorrow's homework is most important, so you finish that first. So that has the higher priority because it has the earliest deadline. So that's like a this is like a general glimpse into like scheduling research. Like just pick the task with the earliest deadline. It can seem very simple, but it gets very complicated very easily when you consider multi-core systems and all the other complexity. If you are at all interested, feel free to email me. Like I can go on like a tangent about this for quite some time. Um, so I did some research in priority assignment specifically. How do you assign priorities to different tasks based on their parameters, such that you are able to meet the most deadlines? Like because it may not always be possible, right? There are say you have 3 homeworks that need to be completed tomorrow, but all 3 of them, each of them take 2 days. So like it's not possible to complete all 3 of them. You need to compromise on say quality, or like complete each of them 50%. So there are different things to consider when you consider a when you consider a real world situation. So I did some research on that, and like got a publication out of it, and eventually applied to my PhD as well. So coming to my PhD, stuff that I'm learning now and like working on now towards is, as I mentioned, right from school, I had an interest in teaching. So, and that's why I'm doing a PhD in the first place. I'm interested in pursuing a career in academia. So, doing a PhD, of course, like you learn a lot about how the system works. Because like at different levels, you are aware of only a certain part of it, right? When you're an undergraduate student in college, you are only exposed to certain part of how the university or the department works. When you're a master's student, you're slightly closer. When you're a PhD student, you're working very closely with the professor for your research, so you're able to see what their other parts of their job also look like, which is also a part of a PhD. You are in training to essentially be a researcher, maybe also potentially become a professor. So that's what I'm learning now. And more broadly, my PhD research is focused more towards applied real-time systems, which is basically real-time operating systems. So the Quest operating system is there are other, just like Windows and Linux. There are, for general purpose operating systems, there are real-time operating systems which are used popularly for several applications. A common one, at least as an educational tool, or in like small embedded systems, which is again a session we've had previously, is FreeRTOS. The RTOS stands for real-time operating systems. Quest operating system is actually one that was developed by my advisors group, and that is what I'm working on now, like more development on Quest, the scheduling part of Quest specifically. And also our research group, my advisor's research group at Boston University, is actually working with uh, autonomous vehicle manufacturing company, where this is actually an image of the car that they manufacture. It's not just any random car, which actually runs the operating system that we are developing. So some of my lab mates are actively working on making the working basically to keep it simple, like working on making the operating system suitable for all the things that happen in a car, in an autonomous vehicle, especially. So that is about my a brief overview of my PhD research. Again, if you're, I didn't want to bore you, and I wanted to keep this as generic as possible, so I don't want to go too deep into this. But of course, if you're interested, you can always reach out to me. So a bit about like how you can what are the factors that you need to consider when you choose a PhD is like the most important thing I would say is your advisor, right? It is not enough to say that once. Your advisor can make or break your PhD because they are the ones you'll be working the most with, and they will also be they are also factors in deciding your future career prospects, how your experience is going to be, what you learn. There are some advisors who are more hands off, like they let you do whatever you do, and like they just provide the funds for you, and like maybe they're there to answer any questions if you have any, but like they just leave you alone. There are other advisors who are more involved, who like to interact with you more, who like to know what exactly you're working on more. It depends on your working style. So again, there is no one size fits all solution for a PhD. Especially this is something that you need to consider in your masters, even in undergrad. A little bit is like ranking is not everything, but that becomes even more true the higher you go in your education. Like for undergrad, maybe ranking is sufficient because like if you're looking for placements, probably if you go for a high rank university in a good program, there's a good chance you will get a good placement, right? So we just think about that and we go for that. That was my choice as well, like kind of. So PhD College of Technology is a very good ranked university, a very good ranked college in Tamil Nadu, which is what and like I did not score enough marks in the entrance exams, so I just went with the highest ranked college I could get with my 12th standard scores. But with your master's and your PhD, you are basically personalizing your experience. You are not doing just a general program. Like everybody, there's a class of 60 people, everybody takes the same courses. That is not a PhD. A PhD is a very, very personal thing. Like it depends on your interests, what your goals are. You might want to go into the industry to become a researcher. You might want to stay in academia to become a professor or just a research professor, or you might want to do like a mix of both. Like a lot of things are possible. So depending on your working style, also like you need to choose your advisor properly. Like there are people who have told me several times, like they chose incorrectly because they made the decision in a rush, or they chose rankings over other factors. So again, even for a choice of an advisor, one thing I would say, of course, is contact current students. It is hard to usually get a hold of people. It is fine to send a follow-up email. Usually, it's fine to send a follow-up email once in a week. Like if they do not respond, after some time, of course, if they don't respond at all, you need to understand that they probably won't respond. But like it is okay to bother them maybe a few times, like 2 or 3 times, to because like they may just have missed your email because people get a lot of emails, especially in the US and in universities, even students. So talking to more people and like forming a network is very important, which is why I think the Nalanda Academy, like the mentorship network is like really helpful because like you have a very diverse group of it. So like a diverse group of people in different areas. So you can actually reach out to anybody in whichever area you're interested in. But actually coming to what your PhD might actually look like, this is like a PhD Comics is a very famous website where I mean it's like a running joke, like PhD students run on coffee because of course we are not paid enough to like I guess buy more better food, I guess. But yeah, this is research can tend to feel very, at least to me who's not used to working this much towards a single goal, research can feel very frustrating. Like it is not like say it's not like doing your like college assignment or school assignment where it's like you know what you're going to do. You basically know how you should do it, and like you're just done with it. Like it's not like that. It's not like a project. It's like you don't know how it's done. You don't know what you're going to do. Even your advisor does not know what you're going to do. Like it just happens. Like you are figuring it out as you go with your advisor. That's what research is, right? You're making something like totally new. So it is not always possible to plan every step forward, and like you just need to accept that. If you're at all interested in research, it might sound really like I'm discouraging people, but like it's just good to be honest, I think. And there are people who genuinely like this. So believe it or not. So yeah, I do really like the unpredictability of research and generally academia. But of course, there are like downsides to this. For instance, like today also I'll probably be today is like currently it's Saturday for me here in the US. People usually just work 24/7. A lot of people in academia. You can not work also. Like if you try, you can like avoid it, but like most people do. So it's a running joke. Like in academia, you can decide your hours. Basically, like, you work 70 hours a week, but you can decide which 70 hours that is. So like you already work a lot of time, but you can just decide. You could work like 2 a.m. At night, and like it would be perfectly fine. It's not like you need to go to the office to do something, because you're mostly working independently. Yeah, this is like another comic that highlights like the more frustrating aspects of general research, but it can be a lot of fun. Like it is also good to maybe do if you're not very sure about if you like research or not, or if you're not sure which area you want to get into. It is always great to do a master's, because like that helps you get some general idea of like, okay, this is something that I actually like doing, and like I see myself doing it for the next few years, the next 4 or 5 years. So yeah, that is in general about the PhD. So if you see, I have created like this beautiful timeline, like a beautiful line starting from my high school to where I am now, and like to the future, like a clear narrative, a clear story. And like interestingly enough, like the now I'm working in a group where we work on automotive real-time systems, like real-time systems for cars. And the professor who actually taught me about real-time systems in undergrad actually did his PhD in automotive real-time systems. So that's like a full circle moment, kind of. But usually, this is like my soapbox time, like advice time, more express advice time. Life usually does not go in like a planned straight line. As I mentioned, like I at different points, like at each of these different points, I had different expectations and like desires for how things would turn out. But like basically none of them happened. But at some point, you need to just understand that like um, life is just like dealing with these differences and like making the best of the situation that you're in. You cannot plan every step in the process, as I mentioned, but like you can focus on your final goal, and like that can help motivate you and like keep you going when you feel frustrated. And of course, luck and privilege play very major roles. There are different factors that affect your success. It is not just you. You're not working in a vacuum, right? Like you can have bad professors. You could have like bad situations. You can't control what happens around you too much. But with the right guidance, you can achieve your goal at the end. Like I don't like being like 100% like toxic positive. You can always achieve your goal, but like it is possible. It's not completely impossible. With the right effort and the right guidance, it's definitely possible. And this is like one like big issue I have in general with like the way things are taught in India on average, as I mentioned, is like by the time and I've seen this with my friends usually, and even in myself a bit. By the time people are done with like 4 years of engineering, they have lost all interest in learning. So I would say if you're already in engineering, or like if whichever stage you are in your career or your learning or your education, try to maintain an interest in learning. You need good marks, that is also important. But like, try to maximize the amount you learn from a course as well, because like that is what will keep you going. Because like, as some other mentorship sessions have also mentioned, especially the one on software engineering, a lot of like the more complicated jobs. I talked a lot about like autonomous vehicles and like artificial, a bit about machine learning, and like we've also had sessions about like software development and other areas. Even if there are a lot of other things that you need to learn to do that, at the end of the day, they all depend on like core fundamentals in your area, which you probably learn in like the first couple of years in undergrad. Say in computer science and engineering, you study algorithms, you study data structures. Those are usually things that you can't just leave them where they are. You need to carry them with you. So it's important to maximize what you learn in any course as well. I understand it can be very hard when the entire system is like operating in a way that like you need to get more marks, and that's how you'll get placed, and like it's like a whole rat race. But try to not lose that spark of learning, the enjoyment in learning. And do not believe people when they tell you like, oh, if you study for 12th standard, you are done for life. After this, it's just easy. It never gets easy. The sooner you accept that reality, the better for you. I would say. Again, I don't want to be too negative. It's just that I'm trying to be as pragmatic as possible, as practical, as realistic as possible. It does not help to lie to people, I think. So yeah, that is just the general overview that I had. These are like the references. Some of the images in the presentation, like the computing stack and the presentation of the image of the car, were actually taken from course and research presentations from some of my professors. And this is the operating systems book. If you're at all interested, I would definitely recommend this one. Operating Systems Concepts by Silberschatz, Galvin, and Gagna. There are, of course, online courses. There are NPTEL courses you can take on operating systems, on real-time operating systems, which can give you a real good introduction into the field, and like maybe decide if that is what is right for you. And some other images were taken from Google and like generated using Bing Copilot, which uses Dolly 3. So yeah, that is actually all I had for today. If there are any questions, I'd be happy to answer them as well. Or yeah.
Thank you, Shriram. It's a wonderful session. It's very informative. So I hope the students who have joined already, so they have learned so many things from this session. Let's wait for some minutes.
Mm-hmm.
Let's hope some questions. I'm
Yeah.
just looking for their reply. Just looking for their response. Yeah, like we questions from the students, but I hope they have learned so many things from this session. Uh, uh, this is actually one of the wonderful session I have about
Thank you so much.
mentally. Yeah. So thank you, Shriram.
Of course.
So
Yeah, and as I
I
mentioned,
think
like it would also be like if there are any like later questions, like, or if the video is shared with other mentees, I'd also be happy to yeah, I'm also available by email, so like they can reach out to me that way, if it's not just a straight up session as well. But yeah.
yes. I got your point. So I think we should stop here.
Mm-hmm.
So there is no questions from the students. So let's stop here then.
Okay.
Thank you, Shriram, for joining us.
Thank you so much.
Bye.
Yeah.
Have a nice day.
Yeah, you too.
Yeah, thank you.